Hello and welcome to my channel, The Curious Coder. In today's video, we are going to talk about pagination, sorting and filtering. This topic is a really important part of building real-world applications, and it's also part of my ongoing Spring Boot interview series. To make this easier to understand, I'll walk you through a practical example. Imagine we are designing an employee dashboard for a company. Now companies can have a large number of employees, but our screen space is limited. So it's not possible to display all employees at once. That's where pagination helps us. It allows us to divide our data into pages and we can show only one page at a time. But that's not enough. On a dashboard, we might also want sorting options so users can sort employees, maybe based on their date of joining or maybe arrange them alphabetically by name. And of course, a good dashboard should also have a search bar to quickly find employees by their names. All these are some important functionalities that are generally needed in any kind of dashboard. Now, what if I tell you all of this can actually be implemented with just a single API if we design our pagination, sorting, and filtering logic properly? That's the beauty of this approach, and that's exactly what we'll be building in this video. So let's get started and learn step by step how to bring all these features together. So what I'm gonna do is I'll start with the most basic design, and one by one I'll keep on adding the requirements into it. Okay, that is the approach that I'm gonna use. So I have created this API get employees. Its URL is /employees/list, and in this API I'm calling this method fetch all employees. Okay, so this API right now will fetch all the employees that are present in the database. Okay, so we have this service class that calls this method, and in this method I'm calling the find all method by employee repository. Okay, this employee repository extends JPA repository, and this find all method is an inbuilt method of JPA. Okay, and I'll also show you the employee entity. So we have taken 4 fields: employee ID, name, department, and the joining date of the employee. Okay, and I have already created the connection with database, and I'll not show you the code for that, but I have covered that part in my earlier videos. So you can refer to those videos if you want to know how we make a connection with the database. But right now in this video, I'll not show that. Okay, so in Workbench, we have this table employee, and you can see as of now, I have 25 entries in it. Okay, so the data is total 25 entries, and I'll run the project. Great, so it started on port 8081, and if I hit the API, cool. So you can see that we got all the records, okay, all the 25 entries. But the problem is that we don't need 25 entries. Let's say my UI screen has a capacity of only 5 entries. So at one time, I only need the 5 entries. I don't need all the 25 entries. So how to solve this problem? We'll be using pagination for that. Okay. So now pagination requires 2 things. First is the size of the page, which means that the number of entries that we are going to have in that page. Okay, so as I said that my screen capacity is 5. So let's say the page size is 5. Okay, that will be the maximum number of entries that we can have inside a page. Now, the second thing that we need is page number. Okay, that basically we want to know for which particular page we are trying to fetch the data. Okay, so let me show you how this works. So as of now, when we have not added any pagination, when we hit the API, this query ran behind the scene. Okay, behind the scene it ran select star from employee because it fetched all the employees. Okay, now let's say I want to fetch employees of the first page and the page size is 5. So how can I do that using a MySQL query? Okay, let's imagine this using a MySQL query. So the query will be something like this: select star from employee with a limit of 5. Okay, so this gives me the first 5 entries, right? So we can assume that these are the first 5 entries of the page 1. Okay, the page number is 1 and the entries are 5. So you can see that using the page size, we got this value that we can place in front of limit. Now let's say I want to fetch the data of second page. So how will I do that? So for that, we have this keyword offset. So this means that whatever value I will set against offset, it means that it will skip those values. Okay, so let me show you. Let's say I write 5 over here. So what this is gonna do is that it will skip the first 5 entries and it will show me the entries after that. And since we have a limit of 5, so it will show the 5 entries which are after the first 5 entries. Okay, so what it did was it skipped the first 5 entries from 1 to 5 and then it printed, then it returned the next 5 entries because the limit was also 5. Okay, so you can consider this as the data of the second page. Okay, if you look carefully, you can see that this is the data of the second page. Now let's say my offset is 10 and I hit it again. So in this case, it skipped the first 10 entries and now it's returning the data of the third page. Okay, so I know how I will get this value. This is basically the page size, but I want to know that how I will be getting this value. Okay, if I figure out that how can I get the offset, then my problem will be solved. So as I said, we can get the information of page number and using page number, we can calculate offset. So I'll show you how. Let's say the page number is 3. So we can apply this formula that 3, if the page number is 3, it means that we want to skip the first 2 pages. Okay, so 3 minus 1 equal to 2 and into 5. Okay, 5 is the page size. So the formula is that page number minus 1 into the page size will give you the offset. Okay, it's basic mathematics because for page number 3, we want to skip the first 2 pages. So we'll subtract 1 from 3, we'll get 2 and we'll just multiply it with the page size. Okay, now similarly, let's say if we want to get the data of page number 4. So what we'll do is for page number 4, I'll just subtract 1. So we'll have the value as 3 and I'll multiply it with 5, which is the page size. So I will get the offset as 15, which means that we have to skip the first 15 values. Okay, so if I run this, so you can see that it skipped the first 15 values and we got the data for the 4th page. Okay, so this is the logic that we are going to apply while we'll do the pagination. And the good thing is that Spring Boot already provides an interface for this. Okay, so you don't have to implement this formula and this calculation. We already have an interface called Pageable. Okay, we can use this interface Pageable. I'll show you. Yeah, so you can see that Spring Framework has already provided us with this Pageable, and simply by creating an object of this and passing the page number and the page size to this object, we can perform pagination. Okay, so it's quite simple. I'll show you. What we are going to do is, first, the thing that we know is that we need the information about the page number and the page size. Okay, so that we are going to take an input. So I'll add 2 request parameters. Let's say int page number and int page size. Alright, so these 2 values I'll get from get as an input, and then I will have to create an object of Pageable. Now Pageable is an interface, so what we will be needing a child class to implement its object. So we have a child class page request. Okay, so it's quite simple. It's just a basic syntax. So we call this method page request dot off. It's a static method in this class page request, and in this off method we pass the page number and the page size. Okay, so I'll just show you. I'll pass the page number and the page size. Okay, and this method returns me an object of page request, and you can see this class extends this class, which finally implements the Pageable interface. Okay, so somehow I need to send this object in my repository. So for that I will have to add this in this method. So this method should expect a pageable object. So I'll just add a pageable here, and in this find all method we can just simply add it. Okay, that's it. This is all that we need to do. We just have to add this pageable object in the find all method, and automatically it will run the offset query behind the scene. So all the calculations that was shown to you on MySQL is automatically done by this pageable object. Okay, so from here where I call this, I'll pass this page request object like this. I'll remove it from here, and you can see now this is giving me error because since I have passed this pageable object, so instead of a list it returns a page. Okay, so but since I want a list at the end, so I'll just call the get content method. Okay, so this converts a page into a list. So what this is doing is eventually it will give me only the 5 entries, and it will give me a single page of those entries, and I'll convert that page into a list because on my UI I want to show it as a list. Okay, so it's that simple. I'll just recap. What we did was we just took two input parameters, page number and page size, and I created an object of this class page request using this method of I passed the page number and page size, and I passed it in this method fetch all employees, where I took a pageable reference. So since pageable is the interface, so we can pass a child class object into that, and this pageable reference I passed in this method find all, the JPA repository method. Okay, and using get content we can convert it back into a list. Fine. So this is how it will work. There is one more thing. If we are doing one based indexing, then I need to just subtract one here. So let's say we start our page number from 1, 1, 2, 3 like this. So in that case, I will have to subtract 1. If you start your page number from 0, then you don't have to subtract it. Okay, so it's simple. So I'll just rerun it again. Great, so it started on 8081, and now in the query parameters I will have to take two fields, page number and page size. Okay, so since let's say the capacity of page is 5, so I'll keep the size as 5, and let's say I want to fetch the data of first page, so I'll just give the value as 1, and if I hit the API, great, so you can see we only have the first 5 entries. Okay, now if I change the page number to 2, you'll see that now we have the next 5 entries from 6 to 10. Okay, similarly I can get for any page. Let's say the page number is 5, so for this gives me the last page's entry. Okay, now let's say I change the page size to 10. Okay, let's say my capacity was 10, and if I'm hitting for page number 1, then I get the first 10 entries. For page number 2, I'll get the next 10 entries from 11 to 20, and for page number 3, I'll get the remaining entries. Okay, so since the remaining entries are 5 only, so it will give me the last 5 entries. Okay, so this is how pagination works. It's actually quite simple. Okay, and there is one more change in the design that we can do. I can give default value to these pages. So let's say the UI doesn't send me any page information, so I can have a contract with UI that if they don't send me any page information, then I'll assume that the page number is 1, and I can assume a default size. Basically that depends on the contract that you have with your front end team. So let's say I assume that the default value is 5, and the page number is, the default value is 1. Okay, so this is just my assumption, and I'll just make it as a false parameter. I'll say that you don't need to mandatorily pass this value. If you don't pass it, I'll consider a default value. Okay, so what's the issue? default value is okay, so we will have to take it like this. Default value is 1 and default value is 5. Okay, so this I'm showing you because like this kind of design helps us. For example, when someone just loads the screen, okay, first time they are on the screen, so at that time it happens that front end does not give us any information because they have not particularly clicked on a they have not clicked on a particular page. Okay, so let's say they are clicking on page number 3, so then front end will send, okay, this is the page number 3. But let's say someone has come first time to that screen, so they might not be clicking on the page, and at that time front end might not be sending us any information. So that's why I'm showing you this, that we can keep it required false and we can keep the default value as 1 at our end. Okay, so this is just a simple contract that you finalize with your front end. So I'll just show you this as well. Okay, so now if I don't give any value, okay, I'll just hit employee/list. Great, so automatically I get the data of the first page. Okay, so this is how pagination works. Now how to implement sorting? So for that as well, we'll be needing two different parameters. First, we need to know which field we are going to use to sort our data. And second, we need to know the order of sorting. Okay, whether it will be an ascending order or a descending order. Okay, so I'll just add two parameters like this, add the request param, and let's take a string parameter sort by. Okay, so we'll pass the field name here. Like if we want to sort by the name or if we want to sort by the joining date, so we'll pass that in this column, in this field. And I'll have another request parameter that will give me the direction. Okay, so something like this, sort direction. So in this parameter, we are going to pass ascending or descending. Okay, now like Pageable, we have another class sort given to us by Spring Boot that handles the sorting logic. So this is the class org.springframework. Okay, and we just need to create an object of this class. Okay, and it will automatically handle all the sorting logic. So I'll show you the syntax. It's quite simple. We use a static method by sort.by, and here we pass the field using which we are gonna sort our data. Okay, and then we can just call a method ascending or maybe descending if we want to do it in a descending order. Okay, like this. So this will return an object of sort. Okay, so I'll implement this logic by an if condition, that if sort direction dot equals ignore case, let's say if it's ascending, so we'll create a sort object. Let's create it above this. Sort is equal to null for now, and this sort reference will be equal to sort dot by, and here I'll pass the sort by field. Okay, the field using which we are going to sort our data, and this will be dot ascending. Okay, otherwise this will be sort is equal to sort dot by, sort by, and dot descending. Okay, so this will be the logic, that if we get the direction as ascending, we'll create a sort object with ascending method, otherwise we'll create it with descending. Okay, and now what I need to do is, you'll find it very simple, that I just have to add it in this page request object. Okay, so this page request dot off has another off method that takes a sort input. Okay, so it's quite simple. I'll just add the sort object here, and I have to make no other change. Okay, no other change. We just added this sort object in this pageable object, and it will automatically sort the data based on the field that you will add and based on the direction that you will add. Okay, so let me rerun. Okay, it started on 881, and I'll pass the page numbers as well again. Okay, let's say it's 1 and 5, and I'll take another parameter sort by. Let's say for now we want to sort using the name. Okay, and the sort direction will be, let's say it's ascending. Okay, so now if I hit the API, okay, so you can see that by chance the data is already in an ascending order because the names are A, B, C, D only. Okay, so I'll just change it to descending and that will show this. Yeah. All right. So we have this data. Okay. So what it did was it found out the data in a descending order. So in the descending order, we will have this Yara read as the first entry. Correct. And similarly this Xander Cox and then Wendy Murphy. So we had it in the descending order. So first it will bring the data like that. Then it will apply the pagination on that data. So that's why we got the last 5 entries. Okay, but if you look at it carefully, we wanted the data in a descending order based on name. So that's why these are not the last 5 entries. These are actually the first 5 entries if we go by this logic. Okay, so that's why it will be in the part, it will be part of the first page. Okay, because we wanted the data in a descending order fashion. So in the dashboard, we'll first see the last entries first. Okay. And let's say if I change it to joining date. Okay, so now it's altogether a different order based on the joining date. So you can see if you look carefully that these joining dates are in a descending order fashion. Okay, 23, 6, 8, then this is April, then this is Feb, and then this is January, and this is an year back, okay, 2022. Okay, so this is how we can sort based on various fields, and we can also set the direction of those fields. Okay, I can again change it to ascending, and you'll see now the data is again in a different order. Okay, it's sorted on joining date. So the joining date 2018, this is November, then December. So you can see that this is kind of in an ascending order fashion. Okay, and this is the first page of that data. If I change the page number, then it's a different data. Okay, the one which has a joining date greater than the previous one. Okay, so you can see like starts from 2020. The earlier one ended at 2019. All right. So this is how we can implement our sorting logic as well. We just need to create an object of sort, and we need to pass this object in the pageable object itself. Okay, and automatically it will take care of all the pagination and the sorting. Now we'll again use the same pattern here. So I'll just keep this also as required false, because let's say for some reason front end doesn't send me this sort by or sort direction. So I don't want to break any code. Okay, I don't want to break my API. So I will just keep it as required false and I'll give it a default value. Okay, so that's a very good coding practice. And for default value, I can keep it as ID. Okay, I'm saying if front end is not passing any particular field by which I should sort the data, so I'll keep the default value as ID. That okay, if front end is not sending any field, that means we'll sort using the ID. Okay, and let's say I can keep the direction as well as descending. Okay, or maybe we'll keep it as ascending. All right, so these are some coding practices that we should always follow so that our code never breaks. Okay, because if we'll make it as required true, then front end will always have to send this data, and let's say by due to some XYZ reason they don't send this data, then in that case there will be an exception. So I don't want that, so that's why I've kept it as required false, and at my end I'm keeping a default value. All right. Now how can we implement the search by name functionality, or we can also call it filtering by name. So for that as well, I'll add a parameter at the request param, and I'll just create another parameter string search. So anything that the user searches in the search bar, that string value will be populated in this keyword. Okay, so if user tries to search by an employee name, then that name will be populated in this keyword, and we'll have to keep it as required is equal to false, because it's possible that user does not searches any employee name. Okay, he just comes to the dashboard and he wants to see all the employees in a paginated way, of course, but he wants to see all the employees, not a particular employee name. So in that case, he will not write anything in the search bar, and in that case, we won't get any value against this. So that's why we have to keep it as required is equal to false. Okay, so now how can we implement this? I will have to pass this keyword in this fetch all employees method, and I'll write the logic like this, that if this keyword is null, okay, if search is null, that means we want to fetch all the employees. Okay, like this. So we are not doing any filtering in that case. But if it is not null, then we'll have to filter our data. So how will I do that? I'll just create another method in this employee repository that says find by name, and I'll pass a string name into it. Okay, so what this find by name method will return? Okay, what should it return? So see, we can have multiple employees with the same name, so ideally it should return a list. Now again, we may encounter a same problem. Let's say we have 6 or 7 different employees with the same name, but our screen size is still 5 only, so we'll have that pagination problem. So somehow I need to implement filtering as well as pagination all together. So actually JP allows us to do that. What I can do is, whenever I write a derived query like this, like in the find by name, I can also give another argument of pageable like this, and this will return a page of employee. All right, so this will be my query. Okay, we can just define methods in this repository and this automatically creates it into a query. Okay, and in this find by name, I'll just call it from here, and in this find by name, I'll pass the name, which will be the search keyword, and the pageable object. Okay, so pageable object we have already created, and this object also has a sorting logic embedded inside it. Okay, and since it's returning a page, so I will have to call dot get content. Okay, so my whole logic is that if search keyword is null, then we'll call the find all method, but if it's not null, then we'll call the find by name method along with the pagination logic. All right, so okay, here we'll have to pass this keyword search, and I'll just rerun my project. Okay, it started on 8081, and now I will have to add another parameter, search, and let's say I give this name as the value, and I will just change the page number to 1. Okay, great. So you can see we filtered the data based on this name no right, and we get only the data of all the employees who are named no right. Okay, so as of now I think we have only one entry with this name, so that's why we get only one entry. Okay, now if I change the page number to 2, let's say I change the page number to 2, you'll see that we get no entry. Okay, because you see, try to imagine it on a UI. You are on the first page and there is only one entry. Okay, and it has a maximum capacity of 5. Now if you'll go to the second page, obviously it will not show any data, because all your data is already on page number 1, because it has not exceeded the limit of 5. Okay, so that's why all my entries were here in the page number 1, and that's why I can see this entry when I change my page to 1. Okay, So this is how we can implement pagination, sorting and filtering all together. If you found the video helpful, please like, subscribe and hit the bell icon. Also, don't forget to catch today's tip of the day.